Hello everybody, today we are in NUS Engineering to look for some students to ask them about their knowledge in fluid mechanics. So let's go find some GPV. Hi sir.
Yes.
Are you interested in winning some cash prizes today?
Yes, sure.
Okay, so first and foremost, are you from engineering?
Yes.
Okay, how much is $50?
$50?
Yes, $50. So the question is, can you make water rise from this straw without sucking it?
How is it possible?
So it's possible through
Carry. How is it possible?
I'll give you a hint. So it'll be something relating to Bernoulli principle.
Bernoulli's principle, is it by brewing down?
Not quite, but we'll show you how it's done. I'll be sharing some creative ways to make water rise up a straw without using suction. One way to make water rise up a straw is by heating the air inside it. Here's how it works. When we heat the air in the straw, it expands and some air escapes. If we then let the straw cool, the air inside contracts, creating a lower pressure inside the straw. This pressure difference causes water to rise into the straw. But there are some downside to this method. Heating can take a while, and using a strong heat source near a plastic straw can cause it to melt or release toxic fumes, which we definitely want to avoid. So, while it's a great demonstration of how heating and cooling create pressure difference, it is not always practical. Another way to make water rise in the straw is by increasing the external pressure on the water itself. For example, if you place the straw in a flexible container like a plastic bottle and squeeze the bottle, we increase the pressure on the water surface. This extra pressure forces water up into the straw. However, this method requires sealing the container to prevent air from escaping. In our case, with an open glass, it's not as effective since the pressure isn't contained. This means that while it's a clever method, it works best with sealed containers, where we can build up and maintain the pressure. Now, I'll show a better example that demonstrates the magic of Bernoulli principle. Let's start with the setup. Here, I have a straw inserted into a glass of water. The straw is open at the top, and I'm not going to suck on it. Instead, I'm going to blow across the top of the straw horizontally. Now, as I blow air quickly across the top of the straw, watch what happens. When I blow, water rises up the straw and may even flow out. But why does this happen? This is where Bernoulli's principle comes into play. Bernoulli's principle states that the sum of pressure plus kinetic energy plus gravitational energy is constant. Hence, in a fluid flow, an increase in the fluid velocity results in a decrease in its pressure. In this case, the fluid is air. So now, we have a pressure difference. The pressure at the top of the straw is low because of the fast-moving air. Meanwhile, the atmospheric pressure around the water in the cup is unchanged. Atmospheric pressure acts evenly on the water surface, pushing down on it. Because the pressure at the top of the straw is now lower, a higher atmospheric pressure pushes water up into the straw to balance the pressure difference. Fluids naturally move from areas of high pressure to areas of low pressure. In this case, the water is pushed from the high pressure area in the cup to the low pressure area created at the top of the straw. The faster I blow across the top, the lower the pressure becomes, which allows more water to be pushed by the straw by atmospheric pressure. The result? The water rises up in the straw. This movement shows us how we can use air velocity and pressure difference to move liquids without using suction. And the greater the speed of the air I blow, the higher the water can rise. To sum it up, by increasing the air velocity at the top of the straw, we decrease the pressure there. This pressure difference allows the higher atmospheric pressure acting on the water surface in the glass to push water up into the straw. Therefore, the simple demonstration is a practical example of Bernoulli's principle in action. There are two key limitations to making water rise in a straw: diameter and height. First, the diameter. A wider straw has a larger surface area at the top, which requires a much greater drop in pressure to lift the water, with the same airspeed as compared to a narrower straw. Second, the height. The taller the straw, the more water weight there is to lift. This means we need a larger pressure difference to push the water up a taller straw, which is harder to achieve just by blowing. Together, these factors limits how effectively we can make water rise in the straw.
Wow! I learned something new today.
Wow, congrats, you won!
Thank you.
Psych!